Hello guys, welcome to this lesson on trigonometry, and as you can see I will be focusing on reduction formulas that are in line with grade 11 content and grade 12 content. Okay, so for each grade I've prepared one question. All right, so what do we see? Our frame of reference, of course, it is the cast diagram, and I've prepared it here for us to refer to as we solve these two problems and to remind ourselves of the quadrants as well as the ratios or trig ratios that are positive in each quadrant. Okay, so let's start with grade 11, then we'll move over to the grade 12 question that I have prepared for you. And what I want to say is that usually this type of questions will be simplify the expression without the use of a calculator. Okay, so you need to use special angles, or you need to use what simplification of your expression if you have, for example, like terms, and you need to be able to add and subtract it so that, or subtract them so that you are able to simplify this type of expressions. So let's start right here. Okay, so the trick here is to be able to identify the quadrant and the sign of the trig ratio for each particular, trig ratio that is given. So it's about the quadrant as well as the sign. Okay, so let's start. Cos of 210 degrees. We are identifying the quadrant. In which quadrant is this angle 210 degrees in? It is indeed in quadrant 3. And cos in quadrant 3 is negative. Here we are. Okay, and then tan of 135 degrees, in which quadrant is this one? We are in quadrant 2, okay? So this is quadrant 2. Tan in quadrant 2 is negative. Here we are, okay? This one, sine of a negative angle, negative 60 degrees, meaning that we are starting from 0 degrees, we're going in clockwise direction now. Negative 60 degrees is in quadrant 4. It's just before negative 90, of course. So this is quadrant 4. And sine in quadrant 4 is negative. Here we are. Okay? Cos of 420 degrees. We know that one full cycle, just like in a trig function, it is 360 degrees if you're dealing with sine and cos, because those are the periods for the basic or original sine and cos trig functions. Okay, well, of course, tan is on its own, since it has asymptotes, its period is 180 degrees. Now look at this one, cos of 420 degrees. It means you have passed 360 degrees and it's a positive angle. So we've completed one full cycle, 0 to 360 degrees. Now we are at 420 degrees. So 360 degrees plus what will give you 420 plus 60. So you're back in quadrant 1, because 60 degrees is an acute angle. It's between 0 and 90. So this is quadrant 1. Okay, and cos in quadrant 1 is positive. Here we are, all are positive in quadrant 1. So we then apply our reduction formulas like this. We have cos of what? Quadrant 3 reduction formula, 180 degrees plus what will give you 210 plus 30 degrees. Okay, times 10. Quadrant 2 reduction formula, you have 180 degrees minus 45 degrees will give you 135 degrees. Over, okay, sine of a negative angle, it is negative. Okay, it's already acute, so we bring out the negative sine 60 degrees. Okay, and we leave it at 60 degrees because we recognize that 60 degrees is a what? I hear special angle. Well, that's true. Okay, so times cos of 420 degrees, not acute, we need to reduce it. Okay, so it's cos of 360 degrees plus what will give you 420 degrees. This is indeed plus 60 degrees. Okay, good stuff. So what did we say now? In quadrant 3, cos is indeed negative. So we reduce it to its acute angle, however, bring in the negative cos 30 degrees, times. In quadrant 2, tan is negative, so we reduce it to its acute angle, becomes negative tan 45 degrees over what? Okay, let's just write it like this, right? Times cos of what? 360 degrees plus 60, this is quadrant 1, cos is positive in quadrant 1. So we reduce it, is cos 60 degrees. Okay, so what do we see? 30 degrees is a special angle, 45 degrees is a special angle, 60 degrees is a special angle, 60 degrees again is a special angle. And when you're dealing with special angles, you need to produce numerical what? Values that are equivalent to that special angle for that trig ratio. Okay, so let's do it. Let's deal with the negatives. A double negative will give you a positive. However, you're dividing it by a negative result, so your answer will have a negative sign here. Cos of 30 degrees is indeed square root of 3 over 2 times tan of 45, it's 1. Okay, over sine of 60 degrees is square root of 3 over 2 times cos of 60 degrees, it's a half, 1 over 2. All right. As you can see, the cancellation happens here. Is square root of 3 over 2 divided by itself. It's a 1. So the cancellation happens there. And then 1 divided by a half is 2. Okay. So therefore, our answer becomes negative 2. All right. So I believe this is clear. It is as neat as I could, put it. And we are now moving over to grade 12. Okay. So for grade 12 students, definitely be aware that coming from grade 11, the only new thing that we introduce is double angle identities and compound angle identities, okay, of which form part of simplification of trigonometric expressions. So let's start with this. We are given this expression now, 2 sine of negative 20 degrees times sine of 160 degrees minus cos 40 degrees. How do we simplify this? We start with the first one. 2 is a constant. Okay, let me rather do this. Okay, identification of the quadrant and the sign first. This is in quadrant 1. Quadrant 4, right? Quadrant 4, in other words, in quadrant 4, sign will be negative. Okay, and 160 degrees, it is in quadrant 2, and sign is positive in quadrant 2. Okay, and this one, cos 40 degrees, it is in quadrant 1, and cos is positive there. However, we might need to use double angle identities at this level. Let's see if they do pop up for us. Okay, so this becomes what? The negative comes in front, just like it did for this one right here. So you have a negative 2 sine of 20 degrees. Okay, it's negative in quadrant 4. And sine of 160 degrees is quadrant 2. And in quadrant 2, sine is positive. Okay, so this becomes sine of 180 degrees minus what will give you 160? Minus 20. Okay, minus, for now, let's leave this as it is, cos 40 degrees. Okay, we see that we are heading in the direction of a double angle identity for cos because we see a 20 and a 20 and a 40 degrees. Let's see. Okay, so this becomes negative 2 sine 20 degrees. Sine, reduce this to its acute angle, sine of 20 degrees minus cos 40 degrees. Okay, you are multiplying sine 20 degrees and sine 20 degrees. Okay, so then you have a power of 2 that forms sine times sine. So this is negative 2 sine square 20 degrees. Okay, minus. Now, since you are having a trig ratio involving sine of 20, the expansion for this double angle identity for cos must involve sine, and that allows you to generate like terms, which will allow you to then simplify this guy right here. Okay, however, let us show that this is indeed a double angle. Okay, 40 degrees is 2 times 20 degrees. So this is a double angle of cos. And then in the next step, we perform the expansion of this double angle identity. Okay, so this is a negative 2 sine squared 20 degrees minus what? There are three choices to make all the time for the expansion of the double angle identity for cos. However, the relevant one that we're going to choose here is this one, 1 minus 2 sine squared 20 degrees. And clearly you can see why we do that, because we have a sine squared 20, just produces again for us a sine squared 20 degrees. Okay, so let us continue here. We have a negative 2 sine squared 20 degrees. The distribution of the negative must help you take care of the sign change that happens. This is a minus 1, a double negative gives you a positive 2 sine squared 20 degrees. Okay, so this is negative 2 sine squared 20 degrees plus 2 sine squared 20 degrees. So it is the same thing with opposite signs, therefore we have the right to cancel it. It falls away. What is remaining, the answer is a beautiful negative 1. All right. So guys, this is really how we perform simplification of trig functions under, this topic, trigonometry. Okay, what is the trick? Identify the quadrant that angle exists in, as well as the sign given that particular trig ratio that is associated with that angle. All right, so yeah, I'm going to leave it here, and always use this as a frame of reference whenever you attempt such questions. All right, so thank you very much for tuning in. I'll see you next time. Remember to subscribe and always tune in for these upcoming lessons or the new lessons that I'll be uploading. Sharp, sharp. See you next time.